three types of for loops: one enumerate, one the normal for loop, one your for item in list type of looping construct, and third one is your enumerate function. Three types of for loops, and you have your while and do while, five types. So the whole point of looping is to iterate over any given data structure like a list or an array. If I want to iterate over this, or if I want to list down all the elements of a data structure like a list or an array, that is why I will be using my looping construct. Example for looping is your for loop, your do while loop, your while loop. These three things majorly are used. Now we will actually see how to use our looping constructs, basically your for loop, do while loop, and your while loop. So we'll start with for. Now the syntax for loop, or the simplest type of for loop, is for I. Now for I in range of length of some data structure, I am trying to do something, or the syntax will be something like this. For I in range of length of your data structure. Now this data structure could be a list, it could be an array, it could be a dictionary, or whatever it is. For I in range of length of data structure, you will give one tab space. Once I give one tab space, I can do or I can execute set of n statements. This is the syntax of your if. For I in range of length of data structure, your array or list or whatever it is, I am executing a set of n statements for each one of those items in your data structure. For example, I have my list 1, which or we'll start with this. Yeah. So we have done the range function, right? Range function, we know it has a start, it has a stop, it also has a step. So if I give only one number, it stands for the stop. A start and end are by default 0 and 1. So for I in range of 5, print I. That is, your I becomes your iterable. That is, your I is used to iterate through all the elements in this range. In this case, for I in range 5, print I, and this is Python 3, that's why I have to use braces. So for I in range 5, print I will basically print from 0 to n minus 1, right? Because range 5 only falls between 0 to 4, 5 is ignored. This is the simplest type. For I in range 5, print I. Now I have another list here where I have so many elements, right? Now I want to add all the elements in this list recursively. So in that case, using the first type of for loop, I can say for I in range length of L, what I need to do? First of all, I need to have a variable, right? I need to have a variable called sum. Initialize it to 0. Once that is done, colon, one tab space, I'm going to say sum. I can either say sum equals sum plus I. This is one way of doing it, or sum is also equal to, or sum plus equals I. Both mean the same. Sum equals sum plus I, or sum plus equals I. Both will add sum to I, or I recursively to your sum variable. So I can use any one of them. I will negate this. Then finally, once it exits the for loop, I can just print sum. This we see that I'm getting 45, because I mean the sum of it cannot be 45, right? Length of L. Okay. Line range sum. Okay, 1 second. Let's print I also here. Let's see what we're getting. That is why, because it is just Yeah, it is just adding 1, 2, 3, 4, 5. But I wanted to add the numbers, right? So for I in range length of L, what I should do is I should not just print I should print L of I. L of I is your index, right? L of I is the element because I'm trying to index it. So sum plus equals L of I. Now this will add all the elements. I'm getting 161. See, I'll print both here. I'll print both I as well as L of I. Now this particular first column stands for the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It means that there are 10 elements in this because my for loop runs from 0 to length of L. Since length of L is 10, it runs from 0 to 9. I is only the index. Your first column is only the index, where second column is actually the value of each element. That's why you have I, comma L of I. L of I, when I equals 0, right? When it starts with I equals 0, right? When I equals 0, L of I is 1. That is why I'm getting 0, 1. When I equals 1, L of I is 2. That's why I'm getting 1 and 2. When I equals 3, L of I is also 3. I mean 0, 1, 2. When I equals 2, your L of I is 3. Then at 3 it becomes 5. Finally, the last element, which is when I equals 9, your L of I becomes 66. Finally, I'm getting the sum of all these elements. Right? This is the first way. For I in range length of any data structure, you perform some set of statements. And these statements are performed as many number of times as the number of elements in your data structure. That is why all these statements are executed 9 times, right? If you see 1, 2, 3, 4, 5, 6, 7, 8, 9. So all these statements are executed 9 times because your for loop runs from 0 to 9. Is this clear? First type of for loop. Okay. This we have seen. And every time this iterates, right? Where it starts with I equals 0, it performs all these operations, then it goes back, I becomes 1. If you see the difference in Java, right, I have to manually say for I in the range, for I equals 0, I less than 5, I plus plus, something like that. I have to manually increment it. But here it is taken care by itself. It increments by 1. That is auto incrementation is happening by itself. The compiler takes care of your incrementing and all that. Yeah, so this is another example. I have L equals 2, 4, 6, 8, 10. Again, I'm saying for I in range length of L, print L of I. When I'm saying print L of I am indexing to get all these elements. Initially, when L equals 0, your L of 0 is 2. That is why I'm getting 2 here. And then L of 1 is 4. L of 2, L of 3 and L of 4. That is why I have 5 elements when I runs from 0 to 4. Is clear? Not clear? Change it. Yeah. It's not possible using just this. There is one more enumerate function which we can use in Python. I mean, this is the basic for loop. That also is possible. We can see it in more example. Yeah, so the second type of for loop is the syntax is this for item, and this is mostly used for data structures or to iterate through data structures itself. For example, or the syntax is for item in list. For item in list, perform set of n statements. There we had for I in range of length of list. Here it is just simply for item in list. For example, we had one list, right? L. So I have L here. Let's say I have more elements in L. I have so many elements in L. So when I'm trying to use the second type of for loop, it becomes something like this: for number in L colon one tab space, I'm just printing. Now this becomes your iterable. This is your data structure. This is your iterable. Now your number stands for all these elements. For number in L, if I print number, we see that all the elements of this particular list are printed. Right? For number in L, print number. And now this is a variable, or this is your iterable. So we can take any name we want here. I can give any name. ZZ in L, print ZZ. That also will print because it is just a name of a variable. It will not make any difference if I take any name here. I can take ZZ, any number, AA, but I have to make sure that this and this will remain the same. So for ideally it is item. For item in list, print item. This will again print everything. If I want to add them up, for item in list, item equal, no, again I have to initialize some variable. So again I can have say something like sum s equals 0. I can say s equals s plus item. Finally, I am going to print s to give you the sum 212. Right? The first type of for loop is for I in range length of L, perform n statements. Here for item in list, perform n statements. Two types of for loop. Clear, right? Two types. We have another type. Yeah, if I want to work with both the iterable is your I or item or anything, and I also want to work with the index. That is, I want to work with both the index or the iterable as well as the element itself. We have to use something called enumerate. That is, if I want to work with iterable as well as element, we need to use something a looping construct called enumerate. So we have L, right? We have L defined. Now I'm interested in both the index position as well as the element. So in that case, I have to use for index. Again, these are variable names. I can give any name I want. For index, comma, and it's always in this order: index, comma, element. For index, comma, element in L. Right? For index, comma, element in L. First of all, let me print both. Print index, comma, element. Enumerate of L. Right? Print index, comma, element. So this is the syntax for enumerate. It takes two values. One is for your index, the other is for the element. When I'm trying to use enumerate, right, it's for a very specific function. If I want to work with both the index as well as the element, I will use enumerate, and this has a lot of flexibility, as we will see. So main usage is, if I want to work with both the index of any data structure also with the element, then I will be using enumerate. Now we just did a small example for this. One more thing we can do, if I want to not just print them, I want to work with it, then again if I want to print the sum, I can initialize sum. Also I want to find the index position which has the highest element or which has the largest element. So ideally, if I look at L, it should be this, right? I want the index position of this. So we can do max of L, right? Max of L, I'm getting 77. We studied this, right? Max min functions in list. So what I want to do is, I want to find the sum of all these elements. So I've initialized S there, and these are variables. I need not use index element all the time. I can always say I comma j also, but they will always refer to index and element in the same order. First is index, second is element, right? So I have s equals 0. I'm trying to find the sum of all the elements. So I'm going to say s equals s plus S plus what? J. Okay. Now I want to find the index position where I'm getting the maximum value in that list. What can I do? So first we'll check with this, and then I'll finally print sum is, I'm going to go outside, put a comma and print S. I'm getting 212. Now I also want to check the index position at which I'm getting the highest element in my list. So then I know that I have max of L, right? So I will in this particular loop itself, before the loop I will store max of L in some variable called temp, right? I'm storing temp here. Now I need to check, I need to get that index position which has temp, correct? So in that case I'm saying S equals S plus J. I need to check if J equals temp, correct? If J equals temp, what should I do? Print I. This will take care of. And can you spot the error here? The condition. So I'm getting it at the 10th position. What I did here, I am trying to find the sum of all the elements in my list. Also, I am trying to find the index position where I'm getting the maximum value of my list. So I'm saying if J equals temp, now because I and J, I is your iterable and J is your element. If J equals temp, temp is already max of L. I don't even need this actually. I can straight away say if J equals max of L, print I. This also will give the same value. Is clear? How to deal with three types of for loops. Any doubts in this? For I in range, and then for item in list, and then the third one is for I comma j, or index comma value in enumerate. So okay. One more extension of this is your nested for. We have L here, right? Nested for is one for loop inside the other. Simple as that. For item in list 1, for item 2 in list in item 1. Like let's say I have a two-dimensional list. Yeah, so let's say I'm just creating ZZZ, which is a list of lists. Right? It's a two-dimensional list. It's a list of 3 lists. So I'll use the same ZZZ here. Yeah, or I can just use this. Here I have a list of 3 lists: 1, 2, 3, 4, 5, 6, 7, 8, 9. First of all, I'm going to say for item in X, right? Now this item will refer to each and every element in X, in your X. Your first element will be 1, 2, 3, then 4, 5, 6, then 7, 8, 9. So for item in X, next I want to, so first in your first iteration, this becomes your item, right? Next, I need to get into this list. So I'm going to say for, I can call it as item 1 here. Next I will say for item 2 in item 1, correct? Because item 1 in list refers to this list. Item 1 refers to 1, 2, 3. Next, I want to get into that list also. So I'm going to say for item 2 in item 1, because item 1 is this list already. And so and then I'm going to say print the last iterable, which is item 2. So this will print every element in your list: 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say I want to mark the ending of a list, right? So I think I should put it at this point, right? After I print item 2, before it goes back here, I need to print some demarcation, something like end of a list. So I'm getting 1, 2, 3 end of a list, 4, 5, 6 end of a list, 7, 8, 9 end of a list. So here, this is an example for nested for loop. I'm trying to write a for loop inside another for loop. So in that case, the syntax is for item 1, I can actually call this list 1. This becomes much more clear. So list 1 is a list of 3 lists, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. For item 1 in list 1, so item 1 in the first iteration will refer to the first list 1, 2, 3, right? For item 1 in list 1. Next, for item 2 in item 1, now item 2 will refer to 1. In the next iteration, in the nested for loop, next iteration item 2 will refer to 2. In the next iteration, item 2 will refer to 3. That is the end of one iteration for the nested for. Then it will exit the nested for and go back here. Next, your item 1 becomes 4, 5, 6. Now I have to iterate through these elements. So item 2 first becomes 4, then 5, then 6, and then this becomes your item 1. It's clear, right? It's self-explanatory, I think. So I'm going to get 1, 2, 3 end of list, 4, 5, 6 end of list, 7, 8, 9 end of list. Okay, so if that is clear, I'll move on. Is it clear? Okay. So we have while loop. The syntax for while loop again is while some condition, and as long as this condition is true, I will execute some set of statements. It is very similar to your for loop, or it is like a combination of for and if, because I'm checking some condition, also I'm executing some statements. Like it is like an if statement, but also I'm checking a condition at every instant. For example, if I write while 1, I'm going to print some random thing, and then what do you think this does? What sort of a loop is this? It's an infinite loop because it will keep on executing. While true, print that. So it will never stop. As you can see, it's still going on. So this is okay. The syntax is while some condition is true, I am executing some set of statements A1. While some condition, I am executing a set of statements. Your first example, I have I equals 1. While I is less than 10, again colon, I am entering my while loop. I am printing I square, and then I am incrementing I equals I plus 1, and then finally when this condition fails, it will exit the while loop and then it's going to print by. If I execute this, it is printing all the squares of numbers from 1 to 10, right? Now the difference between your while and for is for actually first of all checks the performs something and then checks the condition, whereas your while will first check the condition and then perform a set of function. So first it is going to check. I've started with 1, right? It will first check if 1 is less than 10. If it is less than 10, it will execute these statements, and then it will go back. Next I becomes 2, and it will check if 2 is less than 10. If it is true, then it will print this. Then I have to increment here again. I can also do this, right? This is an example for you asked that, so I can do it this way also. I can do using a while loop. For also there is a way, but this is one of the ways. Which part? No, it will not even run. Okay, let's see. Yeah, because I is always equal to 1, right? It keep on running infinite. Yeah, if you don't increment, I will always this will keep on running because I will always be less than 10, right? But if you wanted to end somewhere, then I have to say I equals I plus 2 or 3 or whatever, right? This is your while some condition, perform some statements, and you can loop over it. That was your while condition. Right. Then you have something called as your break. Now break is used basically or mostly in debugging. If I'm trying to debug any script which has errors, then I will be using my break statement. For example, suppose I'll make a small use case. I have names here. Yeah, I'll just give a couple of names. I have these names, right? Assume I have 1,000 names like this, and assume I'm searching for one person who has defaulted the loan payment, and his name is something like say John, right? I have a list of names. I want to search for a person named John, and as soon as I find that name, I want to exit my loop and print that John has been found. So in that case, I have to say for name in names, simple loop. I'm going to say if name double equals, or since we have done starts with, right, it's a string. So name dot, I just know that his name starts with J, but I don't know what's his full name is. So if name dot starts with of J, right, what I want to do, as soon as I get his name, I want to break. I want to break, and after I break, I also want to print something like John, or let's say culprit found, and culprit found name is name. What happened here? For I have names defined. I have names defined. I'm saying for name in names, I just know that the culprit's name starts with J, and as soon as I get his name, I need to break. So what is necessarily happening here is your break statement is basically used to stop your iteration. If I'm using a for loop or a do while loop or an if loop or whatever, any sort of looping construct, if you want to break at any point of coding or of iterating, if you want to stop at some value, then I use break. So if some condition break, so it will stop and it will exit the for loop at this point. So if name dot starts with J, I'm breaking. I'm exiting the for loop and I'm printing culprit found name is, and the name will obviously, because it would have stopped at that point, wherever it finds a match with this, wherever it finds a match where the name starts with J, it will break. So the name value, if I print name here, it will still be John because it stopped at John. It's not gone beyond that. Making sense? Then it will stop there also. Like now I can check one more. If that is there, like so suppose you are saying here, right? Suppose here only I'm getting John. Suppose, or I'm getting I have Jyoti, but I'm only interested in John, right? So in that case, I know that his name starts with J and ends with N. If name dot starts with J, and I can give this again, and instead of starts with, I have to give ends with. Ends with N. Now it is still that. Name is still John. But if I don't give this, oh, I didn't execute this. I'm getting Jyoti because I'm only checking for starts with. So you should be able to use your dot starts with and dot ends with pretty effectively. Is clear how break is used? So again here I'm iterating 100 times, and as soon and every time I'm printing I, but at the instant where I becomes more than or equal to 34, I want to break. So that exactly that is happening. It stops at 34. Now the exact opposite of break is called continue. That is, even at some point you even if so basically again this both break and continue are used for debugging mostly. So break is used to exit a loop, whereas continue is used to continue the execution even when you face some sort of a let's say an issue, or you face some sort of error prone statement. Even if there is a chance of an error, if you want to continue execution, I will use continue. So over here I have ABCD, right? Here what I want to do is, when I reach Z, I want to just continue. I don't want to stop. So it is not stopping. For I, so my names is ABC, ZRP, right? I'm saying for I in names, I'm first printing I, and if I becomes equal to Z, don't do anything, just continue as it is. So this will not have any effect. It will just continue. But the main use case of continue is if you have a statement that might throw an error. Right? If it throws an error, then I can always use this continue to continue the execution, even though it might throw an error. So a small, we'll see an example for this probably in the next class. How to use continue when you have a code that is throwing an error. Yeah, so this continues the rest of the loop. Sometimes when a condition is satisfied, there are chances of the loop getting terminated. This can be avoided using your continue statement. That is your continue. So we've done all this. We just left with one small topic. It's called list comprehension, but I think this we'll do it in the next class. Okay. So this is for today. Covered looping constructs, if and looping basically. All these are done. So we are left with functions.